Welcome, my dear student, in our math program for secondary 3. Dear student, now we are taking new lesson in dynamic. It's called the first law of Newton or Newton first law. أعزائي طلبة وطلبات شهادة الثانوية العامة، أهلا بكم. النهارده إن شاء الله هناخد درس جديد في الديناميكا اسمه القانون الأول لنيوتن. طبعا احنا عارفين إن القانون الأول لنيوتن هو إن الجسم بيحتفظ بحالته من حالة السكون أو حالة الحركة ما دام لم تؤثر عليه جسم خارجي. أتمنى أن نوفق إن شاء الله في هذا الدرس بإذن الله. Newton's first law. As the first types of forces: nuclear, magnetic, electric, gravitation, mechanics. Types of forces. All types of forces, we have 5 types of forces. Now we are start from Newton's first law. What is the Newton first law? Everybody, dear student, preserves in a state of rest or of moving uniformly unless acting upon by an unbalanced external forces by an external effect. Remark: the body at rest preserves at rest unless act upon by a force to move it, and the body in a uniform motion preserves at motion unless act upon by a force change its motion. Number 2, in the formulation of the law, the expression force means resultant of all forces which acting upon the body. The force is measured by Newton unit. Number 3, the law of Newton, the two states, rest or moving, of rest and uniform motion, natural state of the body. Remember, the law of Newton means the two states of rest and uniform motion in natural state of the body. When the resultant of the forces acting in a body equals 0. Number 4, the law shows the body which is at rest or moving uniformly in a straight line. Inertia principle. Everybody, as much as in each state, endeavors to preserve its present state, whether it be of rest or of moving uniformly forward in straight line. A force acts the effect. Force acts the effect which change or tries to change the state of the body, condition of the rest, or of moving forward in straight line. This means of force, effect, which change from state or from moving forward in straight line. Example: look at in the opposite figure, we have body. The first, we know body at rest and a system of force acting on it. In the opposite figure, look at, we have the unknown forces act on the body from the rest. We find the value of the first force and the second force. Solution: look at, the body is at rest state, the vertical are in equilibrium we have in equilibrium F2 plus 40 equals what? Equals 70. The equation F2 plus 40 equals what? Equals 70. What is the value of F2? 30 Newton. Why? Because F2 equals 70 minus 40. We have body in rest is in equilibrium. Vertical equation is F2 plus 40 equal 70. In this case, F2 equal 30 Newton. Horizontal forces in equilibrium also. F1 equals 20 plus F2. Then F1 equal 50. Why? Because F2 equals what? Equals 50. We have two forces, F1 and F2. F1 50, F2 30. The body act on it, F2 in vertical motion or vertical equation, F2 plus 40 equals 70. In this case, or in equilibrium state, must F2 plus 40 equals 70. In equilibrium, in this case, F2 equal 30. F1 equals F2 plus 20 Newton. F1 equals 20 plus F2 by substitution about F2 equals 30, then F1 equals 50. Dear student, in this example, we know that the body in an equilibrium, then we have two equations. The first is vertical equation, the second is horizontal equation. By substitution, about given to find the value of unknown forces. Look at another example. Look at the student in the opposite figure, a body act on it more forces. We have two equations in an equilibrium. Find body moving horizontal in the direction shown. Look at the right, body moving of the right. When body moving in the body, horizontal body moving horizontal in the direction of the right, we have more forces act on the body. Left hand side 300 Newton, 120 Newton, and right to F1 90 Newton. In vertical 400 Newton up, F2 down, 240 down. What is the required? This body is moving with uniform velocity of magnitude 8 meters per second. Find the value of F1 and F2. Solution. Look at, dear student, the body is in uniform motion state. What do you mean in uniform motion state, dear student? Horizontal are in equilibrium. Horizontal equation. Dear student, we have the first equation 2F1 plus 90 equals 300 plus 120. Why? Because the body is moving with uniform motion. Uniform motion means the horizontal equation is 2F1 is an equilibrium plus 90 equals 300 plus 120. After that, find the value of F1 by adding 300 plus 120 minus 90. After that, divided 2. Answer is 165 Newton. In horizontal, then F1 equals 165 Newton. Therefore, vertical are in equilibrium when 2 or F2 plus 240 equal 400. To find the value of F2, look at, dear student, 240 plus F2 equal 400, then F2 equals 400 minus 240 equals 160 Newton. Dear student, we know that if the body is moving with uniform motion, we have two equations. The horizontal equation is an equilibrium, the left-hand side equal right-hand side. The vertical equation also is an equilibrium to find F1 and F2. Dear student, look at another example. This example, a train of mass 200 ton moves under the action of resistance proportional of the square of its velocity. If this resistance is 9.6 kilogram weight per ton of the mass, remember mass of train is 200 ton. If the resistance is 9.6 kilogram weight per ton of mass of the train when the velocity of the train is 72 kilometer per hour. Find the maximum velocity for the train if the engine of the train can pull it with a uniform force of magnitude 4.32 ton weight. Dear student, the required is maximum velocity for the train if the engine of the train can pull with uniform force of magnitude 4.32 ton weight. Solution. Dear student, resistance R1 per 9.6 per 1 ton. Remember, mass of train 200 ton. R1, resistance of the train 9.6 times 200 equals 1920. V1 or the first velocity is 72 kilometer per hour. Let resistance R1 when the velocity of the train V1. There is a proportion between R1 and V1. R2 resistance when the velocity is V2. What is the relation between resistance and velocity? Excellent student. Since resistance is proportional to the square of its velocity, what you mean? R1 over R2 equal V1 square over V2 square. Remember, R1 over R2 equals V1 square over V2 square. R1, the train reaches the maximum velocity when the resistance is completely equal to force of pulling the train. What you mean? V2 maximum velocity for the train, therefore R2 is 4.4320 ton weight. by substitution, R2 with kilogram multiply 1000 ton, each ton is 1000 kilogram, is R2 becomes 4320 kilogram weight. When R1 over R2 equal V1 square plus V2 square. Why? Because there is proportional between resistance and the velocity. R1 over R2 is equal V1 square plus V2 square. By substitution is 1920 over 4320. Then by substitution we find the value of V2. By using cross multiplication we find the velocity of the train is 108. Remember, dear student, we have relation is the mean relation between R and V. R1 over R2 equal V1 square over V2 square. By substitution in this equation, find the value of VT, V2, the velocity of the train when reach the distance, then V2 equals 108 kilometer per hour. Now we are translate to important example. Parachute land vertical as the parachute is open if the total weight of the parachute and equipment is 90 kilogram weight. The resistance is proportional to the square of its velocity. Remember, dear student, resistance in this case is proportional to square of its velocity, and longing maximum velocity of the parachute is 15 kilometer per hour. What is required? Find the air resistance of the parachute when his velocity is 10 kilometer per hour. Solution. Dear student, look at, we have parachute reaches the land maximum velocity when resistance is equal to the weight of parachute and his equipment. What is the, if R1 is the air resistance, V1 velocity of parachute. Remember, we have R1 the air resistance when V1 is velocity of parachute. Therefore, R1 is 90 kilogram weight when V1 equals 15 kilometer per hour. Remember, there is a relation between resistance R and square of the velocity. R1 equals 90 kilogram weight. V1 equals 15 kilometer per hour. If R2 is the air resistance when the velocity of parachute equals V2, what is the relation? R2 is unknown when V2 equals 10. By using the relation, therefore R1 over R2 equals what? Excellent student, V1 square over V2 square. Remember, dear student, this example is very important in our life. We show the parachute drop from the plane. The parachute has weight, and equipment has also it. This relation between resistance of the air and its velocity. R1 over R2 equal V1 squared plus over V2 squared. What you mean? The relation between resistance of the air equal the relation or the ratio between square of its velocity. Remember, by substitution about 3 known to find the resistance of the air. Look at R1 over R2 equal V1 square over V2 square. What is the value of R1? 90. R2 unknown. V1 equal 50. V2 equals 10. By using cross multiplication to find the resistance of the air. R2 equals 40 gram weight. Remember, dear student, there is relation between the resistance of the air and square of the velocity is directed relation. When R2 equal 40, V2 equals 10. But when R1 equal 90, then V1 equals 15 square. 15 squared 225. 10 squared is equal 100. We cross multiplication to find the value of R2 equals 40 gram weight. Look at, dear student, another example. A body moves in a straight line under the action of 3 forces. The first force, F1, 4I plus 3K, F2, I plus 4J minus 15K. Remember, dear student, body moves in a straight line under action of 3 forces. The first force, F1, 4I plus 3K. Second force, I plus 4J minus 15K. Third force, F3, such that its displacement vector S is given as function of the time by the relation S is 2Ti minus Tj plus K. Find the magnitude of the third force, F3. Solution. Since, dear student, displacement S is equation 2Ti minus Tj plus K. Therefore, what is the velocity is derivative ds respect to the time t. What is the derivative ds respect to time t? 2I minus j. Therefore, we find acceleration by using derivative of velocity respect to the time t. Then, in this case, A equals 0. Why? Because the constant V is constant, 2I minus j, but A dV by dt is constant. Derivative of the constant equals 0. The body moves with a uniform velocity of magnitude √5 velocity unit. Then F1 plus F2 plus F3 equals 0 by substitution about F1 and F2 to find the value of F3. F3 in this case equals negative F2 negative F1, or F3 vector equals negative F1 minus F2. we find the value of vector F3 or force F3 by subtraction from F2 from negative F1. Answer is negative 4, 0, negative 3 plus 1, negative 4, 15. Then F3 vector negative 3i, negative 4j plus 12k. By using norm f of 3, negative 3 for all power 2 plus negative 4 power 2 plus 12 power 2, F3 equal 13 force unit. Dear student, look at F3. What is the force 3? The body act on it 3 forces, F1, F2, F3. We have F1 and F2, F3 unknown. We know that the sum of F1 plus F2 plus F3 equals 0. By using or substitution about F1 and F2 to find the value of F3, we know that F3 equals negative 3i, negative 4j plus 12k. But the norm of F3, by using negative 3 for all power 2 plus negative 4 for all power 2 plus 12 for all power 2 under square root, answer is square root 9 plus 16 plus 144, answer is 13 force unit. What do you mean? We have 3 forces. If 3 forces act on the body and with uniform, then sum of 3 forces or resultant of the 3 forces equal 0 or must be equal 0. The resultant, what you mean resultant of 3 forces? We mean sum of 3 forces equals 0. What you mean? F1 plus F2 plus F3 equals 0. We add F1 plus F2 to find the value of F3 by negative sign, or we find F3 by equals negative F1 negative F2. After that, we calculate the value of F3 negative 3i negative 4j plus 12k. Remember, dear student, the force in this case in 3 directions. In direction I, direction j, direction k. In direction I, negative 3, its component, negative 4 in direction j, second component, 12 in third component k. Then what is the norm of this velocity? The norm is square root the first component square, second component square plus third component square to find the value of the force or the third force F3 equal 13 force unit. Dear student, in this example, we know that if we have 3 forces acting on the body, the resultant equals 0. If we know the 2 forces to find the third force, we substitution about the first force and the second force to find the third force. After that, we find the magnitude by using norm this vector force by using square root the first component power 2 plus second component power 2 plus third component power 2 equals the magnitude of the third force. Dear student, I am very happy to spend such time with you. Don't forget, math simple, think, work, produce.